Characteristic number 2 is wondering when are there going to be horizontal asymptotes and when are we going to have these diagonal oblique asymptotes. So we've got a function here, negative 4 over x plus 4. Oops. This one right here is going to have an asymptote at y equals 0. First of all, we can use what we already learned from characteristic 1 in that this one has a non-permissible value at negative 4. It doesn't simplify, so at negative 4, we have our vertical asymptote. But how do we know when we're going to have a horizontal asymptote? How do we know when we're going to have an oblique asymptote? Well, the way that you're going to tell is by looking at the highest degree that occurs in your function completely. So in this one, in negative 4 over x plus 4, the highest degree is x. And remember that horizontal asymptotes, they tell us what happens when x gets really, really big. So if we just put a very, very big number in for x, can you see that this function is going to get really close to 0? So one way to look at that is if you look at the highest degree, in this case it's an x, and you ignore everything else and just label the highest degree in both the numerator and the denominator. So the highest degree is x. We have one x on the bottom. How many x's do we have on the top? 0. If you simplified this, you get your horizontal asymptote. So in some cases like this one, it does simplify. It becomes y equals 0. In our very first example that we looked in the getting started, the highest degree in this whole thing is a degree of 1. If you ignore everything else, you have 3 x's on the top, 1 x on the bottom. That's simplified to 3. And so that becomes your horizontal asymptote. How do we know when we have something other than a horizontal asymptote? Well, this one is going to have, again, the textbook does go into a little bit of a more complicated way of explaining it. I'm going to tell you the simple way is when x gets really, really big, you can ignore the other numbers. What's the highest power in this one? Power of 1. If you do 2x over x, you get 2. So that is the way that you'll find out if you have a horizontal asymptote. Now here's the case, x squared over x plus 1, where if you look at your highest power, if we use that same strategy, my highest power is x squared. I have 1x squared on the top. I have no x squared on the bottom. Something divided by 0 is not possible. Okay? So this may occur in an oblique asymptote. You first have to check and make sure you do all the work first, make sure there's no holes and anything like that. In this case, nothing simplifies. There's no holes, so this one will have an oblique asymptote. To find the equation of your oblique asymptote, you're going to use synthetic division and divide, or long division and divide. If we divide x squared by x plus 1 using synthetic division, well, that would be a 1, 0, 0, because there's x squared plus 0x plus 0. If you're dividing by x plus 1, you'd put a minus 1 out in front. Bring down the 1, multiply, add, and you get this answer would mean x minus 1, remainder 1. The equation of your diagonal asymptote, you can ignore the remainder, and whatever you get when you divide will be the equation of your oblique or diagonal asymptote. So they summarize things here a little bit. Let's look at example 2. So a step for graphing all of these rational functions, you always want to factor first to see if anything cancels out. Because the very first thing you're going to look at is my non-permissible values. Are my non-permissible values wholes, or are my non-permissible values asymptotes? So for this first one here, I can factor the top. It's going to be x plus 7, x minus 1, all over x plus 2. Nothing cancels out. I have a non-permissible value. So 1 non-permissible value. And we'll summarize this later as far as as we add all the characteristics, if we had to do it all at once, what you would do first, what you would do second. We have a non-permissible value. X can't equal negative 2. And that is going to be a vertical asymptote. So we will have a vertical asymptote at x equals 2. So a little bit of a note on notation here. When we talk about a non-permissible value, we put a line through saying x can't equal something. But when we talk about the equation of an asymptote, an equation always has an equal sign. So your equation of your asymptote will be x equals 2. And when you label it on your graph, they're going to be picky that you don't have that line through your equal sign when you're labeling your asymptote. So it has a vertical asymptote. That's going to be important. Now we're going to look, does this one have a horizontal or an oblique asymptote? So the second thing you're going to look at is whether things have horizontal asymptotes or oblique asymptotes. In this case, the highest power in the whole fraction is an x squared. If you look at, you have 1x squared on the top, you have no x squareds on the bottom. This is not possible. And that tells you you're going to have an oblique asymptote. To find that oblique asymptote, you're going to have to use synthetic division. So in this case, we have x squared plus 6x minus 7 divided by an x plus 2. So for synthetic division, back from chapter 1, you'd put a negative 2 out in front. Bring down your 1, multiply, add, multiply, add. And with the oblique asymptote, you can ignore the remainder. Your equation will just be y equals x plus 4. So I know that this question just said to predict whether or not it has a horizontal or oblique asymptote and to write the equation of that, which we've done already. What I'm going to do with all of these ones, because we're leading towards graphing them all anyways, how would we use this to help us graph? And that's why sort of number 1, you're always going to look at your non-permissible values. Your non-permissible values here, they tell you that you're going to have at x equals 2 a vertical asymptote. Next, we found out that this one has an oblique asymptote at x plus 4. Well, 1, 2, 3, 4, that would be a y-intercept of 4, a slope of 1, and that's our second asymptote.
Would you ever have oblique asymptote along with the horizontal and vertical, or do we have?
You won't have an oblique with the horizontal.
That's not possible?
No, because the oblique, like the horizontal, is telling you what's happening to the graph at its endpoints.
And what does the oblique one do?
So the same thing, the oblique one is telling you what's happening when x gets really, really big.
Approaches.
Yes.
So if there's a vertical, there's always going to be an oblique or a horizontal, or is there times when it's just a vertical asymptote?
Usually you'll have the vertical with something else. Okay? So at this point, if you wanted to graph it completely, you would need some other points. Because the next thing you're going to do is look at your vertical asymptote at x equals 2. It splits your graph into two sections, values that are before that non-permissible value and values that are after. So now you go back to your equation and you say, well, what might be some easy points for me to figure out? Can you see that if you plug in 0 for x, that's finding your y-intercept. You're going to get negative 3.5, or negative 7 divided by 2. So I can label that point on my graph, 1, 2, 3, negative 3.5, and that's easy to label. Some other points that are easy to label, since you were able to factor the top, you can find your x-intercepts easily. X-intercepts are when y is 0. A fraction is only equal to 0 if the numerator is equal to 0. So can you see that at 1 and at negative 7, it's going to be equal to 0. So if I go down to my graph, 1 and negative 7.
Negative 7 won't be on the other side of the asymptote.
Did I? Positive 1? I'm not happy with something here. Did we factor it wrong? Factoring looks good. Our asymptote x can't equal negative 2. So where's our asymptote supposed to be?
-2.
At negative 2. Okay.
Yeah, because I was wondering, because what?
So this one here, oh great. Have to move dot by dot. There we go.
Well, at least the top part.
That makes more sense. So something was telling me something went wrong by the points. As soon as we started to plot our points, because I've had experience with these and I know that things are supposed to approach their asymptotes, when this was an x-intercept and this was an x-intercept, something was wrong based on where that asymptote was. But now, things are going to work out fine. Notice that we have points both to the left of our vertical asymptote and to the right of our vertical asymptote. Once you have those points, the rest of your drawing is just drawing things, oops, that should be smoother, towards your asymptotes. So this section will go down like this and up like that. So you go through your points and approach both of your asymptotes. And what the points will tell you is in which sections. So your asymptotes sort of split your graph into 4 different sections. You have a graph in only 2 of those sections. Part B. Part B is exact same equation, but now your x plus 2 is in your numerator and your x plus 7, x minus 1 is in your denominator. So first thing you're going to look at, do I have holes, or I have 2 non-permissible values. X can't equal negative 7, x can't equal 1. With those non-permissible values, are they going to be holes or vertical asymptotes? They're going to be vertical asymptotes. You're going to have a vertical asymptote at x equals negative 7 and a vertical asymptote at x equals 1. Secondly, what's the highest power in this whole equation? Is an x squared. We have 1x squared in our denominator. We have no x squareds in our numerator. Anytime the degree is bigger in your denominator than your numerator, you will have a horizontal asymptote at y equals 0. So now going to graph it, we can label at negative 7. And at 1. Those will be our vertical asymptotes. And our horizontal asymptote will be at y equals 0. Again, if you have a red pen, do all of your asymptotes in red.
It's almost like a sign you showed.
The next part is how do we graph this? Well, your asymptotes split things into 3 directions, into 3 parts. You can't go through your vertical asymptotes because those are non-permissible values. Your horizontal asymptote tells you about the end behavior. In other words, it tells you when x gets really big, it's going to get close to that asymptote. And when x is going to get really big negative numbers, it's going to get close to that asymptote. Your horizontal asymptote doesn't help you in the middle. Sometimes it helps a little bit, but usually it doesn't help very much. So in this case, what are we going to do? If we plug in 0 for x, because that's usually an easy one, can you see you're going to get negative 2/7? So we have one point that we could label here, 0, negative 2/7. Is our numerator ever equal to 0? Oh, this is a really complicated graph. I like it. Do you see that your numerator is equal to 0 at negative 2? So this is where your life feels weird because you actually plot a point on an asymptote. Okay, again, a horizontal asymptote tells you what happens when x gets big or when x becomes big negative numbers. So it is okay at this point that you have negative 2, 0 right on that horizontal asymptote. We have some points on our graph, but they're only in the middle section. In fact, I have enough in the middle section to say that this has to go down here. I actually don't quite have enough. It doesn't tell us if it's going to go up or down after this, so we might need to do another point. And what comes down to is a lot of table of values. So if I plugged in another point, for example, if I plugged in negative 3, and all I'm going to do with negative 3 is check what happens. You plug negative 3 into the top, can you see that I would get a negative 1? Negative 3 here, I'm going to get 4. And negative 3 here, I'm going to get negative 4. If you just think about positive and negatives and not think about what number that is, what's going to happen when you plug in the negative 3? It's going to be negative here, positive here, and negative there. Is that whole thing going to be positive or negative? Positive. So because of that, I know that it has to continue up. It can't go positive and come back down negative afterwards, because then I would have another x-intercept, and the only x-intercept is at negative 2, because the only place that this graph can equal 0 is at negative 2. We've graphed our middle section now. To graph our section to the right of x equals 1, you'd have to plug in 2, or any number bigger than 1. 2 seems like a good choice. If I plug in 2, can you see that you would get 4 on the top, 9 on the bottom, and 1 there? 4 9ths. So you could label that point 2, 4 9ths. And because that's in that section, that's enough to say this section has to look like this. It can't go through that horizontal asymptote again because we already found the only x-intercept for that. Same thing, we could plug in negative 8. What happens when I plug in negative 8? Can you see that the top would be negative 6? This will be negative 1, and this will be negative 9. So the whole thing, when you simplify it, becomes negative 6 over 9, which is negative 2/3. So if you plug that point in, negative 8 comma negative 2/3, it's in this section, and that's enough to draw it towards your asymptotes. That's a really complicated graph in the end. It has a horizontal asymptote, even though your graph goes through it in the middle. And it has 2 vertical asymptotes. Okay, let's try some for practice. We'll work on them right now. 6 and 7.